Welcome to another video of Metacentric Bangladesh in the series Electrical Engineering. This is lecture number 2. The topic is voltage divider rule, or in short we can say VDR. This is Mahmudul Topu. So I'll be teaching you about VDR. So first of all, we actually know that VDR happens whenever we faces a series circuit. So voltage gets divided in series circuit, we already know that. So let us consider that this is a very simple circuit consisting of R1 and R2, two resistances or resistors in series. So the applied voltage is V and the current is I. So the current I remains same for all resistances. So let us consider that V1 is the potential difference between two terminals of R1. In this case, the blue terminals are for R1, and V2 is the potential difference between two terminals of R2. In that case, the pink terminals are for R2. So using Ohm's law, we know that V equals IR, or we can write I equals V by R. So using this simple formula, we will calculate V1 and V2. So we can write V1 equals I into R1 using Ohm's law, right? Or this is equation number 1. Or we can also write V2 equals I into R2. So let us consider that in the two equations, so equations number 1 and equation number 2, the current I remains the same because this is a series configuration or series combination. So we need to calculate the value of I. So to calculate the value of I, what we need, so we can write I equals V by R. So we actually know the value of V because we have applied V is basically the applied voltage. So we need to calculate the value of R. In that case, R is the equivalent resistance because the resistors are in series. So what we know that R equals, so R equal R1 plus R2. Basically, just because that this is a series circuit, so we know that equivalent resistance is equal to the summation or addition of all the resistances. So in that case, we have only R1 and R2, so we can write R equals R1 plus R2. So let us consider this is equation number 3. So from equation 3, we have I equals V by R1 plus R2, right? So let's plug in the value of I into equation number 1 or equation number 2. So we can write from equation number 1, we can write V1 equals I, that means V divided by R1 plus R2 into R1. So we got the value of I from equation, let us consider that this is equation number 4. So this is actually from equation 4. Okay. So similarly for V2, we can write that V divided by R1 plus R2 into R2. So from equation 2 actually. So in numerator, what we have is that, so we are calculating V2. So in numerator we have R2 into total voltage V divided by, in denominator, divided by the total resistance or the equivalent resistance, that means R1 plus R2. So if we generalize the equation like that, if we want to calculate Vx, in the numerator it should be Rx into V. V means total voltage divided by the equivalent resistance, that means Rx plus Rs, or we can write R of equivalent, right? So this is the generalized form of what we can say that this is the VDR.